Welcome to Spelling Bee Ninja. We're delighted to bring you another engaging episode filled with valuable educational content. Today, we're diving into the fascinating world of circles and the mysterious number pi. If you're curious about geometry, mathematics, or just love discovering new things, be sure to hit subscribe and join our community as we explore the wonders of learning together. Let's kick things off by defining what a circle actually is. A circle is a perfectly round two-dimensional shape, and here's the interesting part: every point along its boundary is the exact same distance from a fixed central point, which we call the center. This constant distance from the center to any point on the boundary is known as the radius. Unlike other geometric shapes that have corners or edges, circles are unique because they are completely smooth and symmetrical. They have fascinated humans for thousands of years and can be found everywhere in nature, art, architecture, and technology. You might find it intriguing that in ancient philosophy, the circle was seen as a representation of divine perfection and eternity. Think about how the sun, tree rings, and even some fruits have that circular shape. Isn't that wonderful? And next, let's identify the key parts of a circle. As mentioned, the center is the fixed point inside the circle. The radius, as we established, extends from the center to any point on the circle. Now, if we extend that radius across the circle, passing through the center, we find the diameter, which is exactly twice the length of the radius. A common formula to remember is that the diameter can be expressed as d equals 2 times r, where d represents the diameter and r represents the radius. Then we have the circumference, which is the distance around the circle. Think of it as the perimeter of this round shape. Another interesting part is the chord. This is any line segment connecting 2 points on the edge of the circle, and the longest chord is, of course, the diameter. Knowing these parts is essential for a deeper understanding of circles in geometry and their applications in the real world. Did you know that the term circumference comes from the Latin word circumferre, meaning to carry around? How cool is that? And now, let's explore the intriguing concept of pi, commonly denoted as pi. Pi is not just a number. It's a mathematical constant that represents the ratio of a circle's circumference to its diameter. This holds true for any circle, no matter how big or small. You might find it mind-blowing that if you take any circle and divide its circumference by its diameter, you will always get the same value, approximately 3.14159, or simply 3.14 for everyday use. Pi is classified as an irrational number, which means its decimal representation doesn't end or repeat. Scholars have been calculating its digits for centuries, with modern technology bringing us calculations to trillions of digits. Pi is fundamental not only in geometry but also in trigonometry, calculus, physics, and engineering. A fun tidbit for you: March 14th is celebrated around the world as Pi Day since the date resembles the first 3 digits of pi. Coincidentally, it's also the birthday of the legendary scientist Albert Einstein. And then this brings us to calculating the circumference of a circle. The formula for circumference can be written in 2 ways: c equals pi d, where d stands for diameter, or c equals 2 times pi times r, where r is the radius. Imagine a circle with a diameter of 10 centimeters, its circumference would be roughly 31.4 centimeters. Understanding how to measure circumference is incredibly pertinent across numerous fields, whether it's in engineering, architecture, or even when crafting computer graphics. A handy tip: when you're doing quick calculations, feel free to use 3.14 as an approximation, but remember that using more precise digits is crucial in situations where accuracy matters. And then next, let's discuss how to calculate the area of a circle. The area is defined as the space inside a circle's boundary and can be computed with the formula A equals pi r squared. If you take a circle with a radius of 5 centimeters, its area would be approximately 78.54 square centimeters. The derivation of this formula comes from ancient methods of approximating circles with polygons. This is important for practical applications, from working out the size of a pizza you want to order to determining the surface area of planets. It's fascinating to point out that the ancient Greek mathematician Archimedes was one of the first to accurately approximate the area of a circle by working with inscribed and circumscribed polygons. And now you might be wondering about the difference between the radius and the diameter. As mentioned, the radius is the distance from the center of the circle to any point along its boundary, whereas the diameter is twice that distance, stretching all the way across the circle through the center. You can think of the radius like a spoke on a bicycle wheel, while the diameter is the line going straight through the wheel. This relationship is fundamental because it aids in calculating other properties, like circumference and area. A fun fact to remember: many everyday items, from gears to coins, are built around these measurements. And then, speaking of geometry, let's talk about chords. A chord is any line segment that connects 2 points on a circle's edge. The longest chord, as you may have guessed, is the diameter. Chords have some remarkable properties in geometry. For instance, if you have 2 chords at the same distance from the center, they are equal in length. Chords also lay the groundwork for many geometric constructions and theorems. Interestingly, in music, the term chord relates to groups of notes played together, and it stems from the same Latin root as the geometric term. This illustrates how interconnected different fields can be. Did you know the relationship between chords and arcs, the curved parts of a circle, is crucial in trigonometry and the study of waves? And now, let's circle back to pi and its relationship with a circle's area. Pi is essential when we calculate the area using the formula A equals pi r squared. This embodies the idea that the area of a circle corresponds to the square of its radius, with pi acting as the constant of proportionality. Discovering this relationship was a significant milestone in mathematics. Ancient mathematicians often grappled with the challenge of squaring the circle, which meant finding a square that has the same area as a given circle, but pi proves it can't be achieved with just a compass and a straightedge. To visualize how the area formula works, picture cutting the circle into wedges and rearranging them to form a shape that resembles a rectangle with dimensions r and pi r. Isn't that an interesting way to understand the concept? And as we reflect on the practical uses of circles in the real world, it's evident they are everywhere. Wheels, bicycle gears, and pulleys depend on circular motion. In architecture, you can find circles in arches, domes, and structural columns, resulting in both beauty and strength. In astronomy, the paths planets take around the sun are nearly circular. Technology has a plethora of circular objects, too, like CDs, DVDs, and hard drives. Even in sports, balls, tracks, and goals exhibit circular shapes. Clearly, the study of circles has opened doors to numerous inventions and insights about nature. A fun fact is that the wheel, a groundbreaking invention in human history, is entirely based on the properties of circles. And then finally, let's explore why pi has piqued the interest of mathematicians for thousands of years. Pi, being an irrational number, doesn't just show up in circles, it is pervasive throughout mathematics, physics, and nature. Its never-ending non-repeating digits symbolize the infinite scope of both mathematics and the universe itself. Historical records tell us that ancient Egyptians and Babylonians had their own approximations of pi. Archimedes made significant strides in calculating it through polygon comparisons, and as recently as 2022, pi was calculated to over 100 trillion digits. The allure of pi is so strong that some people take on the challenge of memorizing vast amounts of its digits, with the current world record being around 70,000 digits. Isn't that incredible? In today's episode, we delve deep into the world of circles, exploring what they are and discovering their key components, including the center, radius, diameter, and chord. We unraveled the concept of pi, understanding its significance and applications in measuring circumference and area. Additionally, we learned how to calculate both circumference and area, the unique properties of radius and diameter, and the role of chords in geometry. We also uncovered the omnipresence of circles in everyday life, from technology and sports to nature and architecture. And lastly, we reflected on why pi remains an enduring mystery and fascination for mathematicians throughout history. Thank you for joining us on this enlightening journey into circles and pi. We hope you've gained new insights and a deeper appreciation for the beauty of mathematics. Remember, whether you're calculating the area for your next pizza or pondering the wonders of the universe, the world of numbers is all around you. Be sure to subscribe for more educational content as we continue to explore fascinating subjects together. Until next time, keep learning and stay curious.